Often the following equation is used as a formula to represent exponential growth or decay. The variables and formulas may vary, but they'll be clearly given in any question. So you're going to get questions with the formula. So for example, y is equal to a e k to the exponent k times t. Y is equal to your final amount. Your final amount's always going to be what you're evaluating here. Your initial amount will always be that number out front, e, and then k is used for the rate of growth or decay. And t is used for time, and whatever units is based on the questions. Now this is actually technically the PERT formula. The PERT is very specific for finance, which is why they use different variables of final amount principal. But really your final amount is still your y value. Your initial amount is still your first number out front, e. Your rate that it changes, which interest rate or growth or decay rate are the same, and then it's your time. So this formula is really the same one. So let's look at an example here. Number 1, there are 10 frogs in the swamp on October 31st. There are 60 frogs on November 15th. How many will there be on November 30th if they grow exponentially? So first we have to find the rate of growth. So we're going to actually find the k value first so that we can use this formula again. So we're still using our formula. We're going to just use it in 2 steps. So I need to pick a final amount and a starting amount. So it gives me a time frame here where there are 10 frogs on the 31st, 60 on the 15th. So 15 days later, there are 60 frogs. So my final amount is 60, my initial amount is 10, and I can find the k value. That was a time period of 15 days. So we'll use 15 for time. So let's solve for k. So we need to divide off the 10. So we get 6 is equal to e to the exponent k 15. I'm going to log both sides because I can't get a common base. So because of the e, we're going to use natural log. Now I'm going to apply the log theorem. So I need to move k15 out front. So this will become a 1 now, and I can divide off the 15. So k is equal to the natural log of 6 divided by 15. So I need that value. So you're going to put that in your calculator. It's very, very important that you do not round this number off. Keep that in your calculator. You don't, even the numbers that you wouldn't be able to see off of your computer screen. That's so important that I want to make a note. Don't round off here. You have to use this entire number in the next step. So in the next step, we're using our formula again. And we're finding in the next period, how many will there be on November 30th? So we have to pick a starting amount. So you need to decide if you're going to use 10 or 60. It does not actually matter as long as you use the correct time period. So for example, if I was to use 60 as my amount, and again, this number's cannot be rounded off. In fact, I'm purposely going to write down all of those decimals. If I use 60 from November 15th to the 30th was 15 days. So then my time period is 15 that I'm putting in. So that should be in your calculator already. That's very important. If not, go put ln 6 divided by 15 back in your calculator. Times that by 15. Then you're going to take e to that exponent, because you have to do your exponents first, times that number by 60. This one worked out to 360, and then we're finding frogs. So this is what this is exactly. I just want to point out, had anyone thought I was going to use 10 instead, you can certainly do that. And you can even check this if you wish, but now you're using a time period of 30 days, and you're still going to get the answer of 360 when you put that into your calculator.